Hello guys, welcome back to John's Workshop, and in this video and maybe the one that follows on from it, we're going to be making a carriage stop for the Harrison M300 lathe. I've made several references to it in a couple of videos, so this is where we're going to actually start that project. So what I'll do is just kill the lights in a moment and show you what I've got up on the screen. I've got some material sort of roughly blocked out to start with. It's probably not the right sizes yet, so I'm going to need to make some cuts probably on the bandsaw. I've now done some preliminary design. I've not completely finished it in CAD, so I'm just going to kill this light and we'll come and focus in on the screen behind me and show you what we're doing, and then we'll crack on with the manufacture. Okay, so we're focusing in on the screen now. I've still not got my CAD package working correctly at the moment, so I'm still not able to export my drawings properly. I'm still not on a licensed version of the CAD system, even though I've purchased that. I've not managed to get that configured properly yet, so I'm still working on the trial license, which doesn't allow me to export the drawings. So I've done a bit of work on the CAD package, and we're going to make this in, I think, fundamentally 3 separate parts. So this is one of the parts. Now originally, when I first designed this, this had a secondary piece of block all in one unit that comes down the front of the bed, if you like. So this is obviously where we locate on the bed, and then there was a part of the block that came down the front, and then the very last part will be the bit that goes underneath that actually does the clamping on the underside. So to make this easy to manufacture, or to make it possible to manufacture, let alone easy, I've had to split this. So basically this will be the top piece. There will be a piece that screws onto that sits down the front of the carriage, and then, sorry, the front of the bed, and then there will be the clamp piece that sits underneath that will be a third separate piece. And the reason for that is probably not immediately evident, but once I start describing it, it may well be. So if you look at the angle I'm dealing with here, if this was a 90-degree angle, life would be much simpler. Unfortunately, Harrison, for whatever reason, decided to make this a 70 degrees sort of dovetail, not dovetail's not the right word, but a 70 degrees V shape. So from a manufacture perspective, for me, certainly at least, without the ability to be able to grind form tools and things like that for the mill, this is a really difficult set of geometry to produce, and trying to produce that with a shoulder in the way down this sort of side here, if this was all one block, would just make that immeasurably more difficult than it already is. So what I have done in CAD is I've modelled in a 10mm end mill, and to get down to this bottom point here, there's enough clearance for a 10mm end mill to sit in here, so I can flank mill through the block this way, and then I can tip and flank mill through the block on the other side, and there's just enough clearance at this bottom point to allow, at this angle, to allow a 10mm diameter end mill to sit in. So I can use a standard end mill to get to this just. Obviously if I'd got this block piece down here as all in one unit, there is absolutely no way I could get in there to do that. I would need a specialist form tool to actually get in there that's ground to the shape, and I don't have the ability to do that. So that's one part of the block. So there's the other view of the same block. So this is the top view. So effectively this is the dovetail slot, or the V slot running through here, with the clearance slot at the bottom. There's 2 clearance holes here for cap head bolts to go through to clamp it to the secondary piece, and then there's a big clearance hole for the actual clamp bolt itself that will go right the way through to the bottom piece that sits underneath the slideway. So it's not complete from a CAD perspective. I've still got to model up the other pieces and dimension them, but certainly in terms of this top block, I've got enough information around me now to start the manufacture. So we'll bring you back probably at the saw when we're just blocking this steel block that I've got out to the rough sizes before we start milling it. Right guys, unfortunately I don't have anything any smaller than this, metal wise, stock wise, in the dimension that I need it, which is the thickness this way. And it's impossible to do a saw cut. Well, it's not impossible, nothing's impossible, but using the vise I can't put a saw cut through here to slice a section of this off. So I've only one option, which is to swarf it off, and I've got no other stock the right size, so we're going to go with that. I think it'll be a good proper test of the mill, because I've not really pushed it in terms of stock removal yet, since I've put the new bearings in, so that'll be good. So that was 2.5mm depth of cut. I think it's probably on the limits of what it will do, judging by the noises it's making. We'll persevere and see how we get on, and I'll bring you back in a bit when we've taken some material off it. Right, we're getting there, guys, with this now. We've played around a bit with the sort of depths of cut, really. I've kept the speed the same, so we're still running at 280 RPM, but 1.5 mil depth of cut, or 60 thou, seems to be the sweet spot. So I'll just show you a bit of that. So that's chewing that off nicely at that. So there's absolutely no way on earth this milling machine would have done that prior to the bearing changes and the head strip down. So I'm pleased with that. I'm nearly there. I'll finish this cut off across, and then I think I've got a finish pass to do, and then I'll bring you back when we're on with the next operation. Okay guys, we've got the block to finished thickness now. So what I've done, in fact I've gone thicker than finished thickness by about 1 millimetre. It really doesn't matter, that's just in fresh air, the top of the block, and I've done that just to give it some more strength from where the top of the V is, and I'll probably explain that once I've cut the V in, if we manage to successfully cut the V in. So I've took the part out, deburred it, flipped it around 90 degrees in the vise, and we're going to put the slot through in this direction. So all I need to do now is set up off this edge to find my centre line of my slot, which is what we're going to do now. Okay, so the next task, when you look at the V slot that I've drawn on the drawing, you've got the V through the block like this, and then at the bottom of the block, at the bottom of the V rather, there is almost a rectangular slot, which is just to give clearance on the top of the slideway. Now that rectangular slot is 5.5mm wide, as I've measured and drawn it. I'm not going to get a 5.5mm or a 5mm end mill down as far as I need to go. I need to go about 17, pretty much 17mm deep. So I don't have anything that long, and I think that would be difficult to get that deep anyway with something that small. So what we're going to do is pop a 6mm end mill down, which is what this is, almost as far as I can go up the flute length, and then I'll put a 5mm end mill in, and I'll have clearance either side on the end mill, which means I'll be able to pitch down and just take that bottom section out, hopefully. So you get the idea. I'll keep plugging away at that, and I will bring you back when we're down at depth. So change of plan guys, rather than mess around with a 4mm end mill right down there, this was going quite well, and the 5.5mm was just something I sketched. Doesn't need to be 5.5mm, 6mm will be absolutely fine. So I just carried on with the 6mm end mill, and I'm not going down quite as deep as I originally planned. Again, there's no need to be that deep. This is just clearance on the top of the V. I've gone down 15mm there in 1mm steps. It's gone quite well, and that will be more than deep enough to clear, well clear the top of the V. So happy with that. So we'll strip that cutter down now, and the next job is we're actually going to tip the head over at 35 degrees to start milling the first sort of angled side of the V, if you like. So that'll be something a little bit different. and I'm just hoping when I tip the head over at 35 degrees, all the work I did rebuilding it doesn't mean that everything's going to start falling out and drop into bits, but we'll give it a try. Oh guys, I think my head needs tramming in. So what I've done is I've put that over at 35 degrees. Now on the scale, on the angular scale if you like, for the head, when it was trammed in with a clock onto the table, the 0 marks were bang on. So I think the 35 degrees will be somewhere near where it needs to be, plus minus quarter of a degree probably. It's probably the best I can hope for. And what I've done is I've put some Sharpie on the top of the block, and I've scribed 2 lines into the Sharpie so that I can see where my end points are going to be each side. Obviously we're only going to machine one side, and then we'll take the block out, turn it round and machine the other side, all at the same setting. Because the head, doesn't matter how far I go down with the spindle, the touch point, if you like, will be the same. It won't change. So what I'm going to do is touch on this corner with the cutter, and then I know what my distance is out that I need to go to get the right overall width, and the depth will be correct as well. The scribe lines are just in case, you know, just to give me a guide to work to. So that's kind of what we're going to do. We'll touch on that corner. I've measured the width of the slot, so I know how wide the slot is. I take half the width of the slot from the centre line, and then I can pitch out in my x-axis by the right amount, and then if I have to move the z-axis in between to get down to the right depth, it won't affect the x-axis numbers that I'm working to, hopefully. So that's the plan. So we'll bring you back in a moment. I'll reposition the camera, and we'll start machining the first side. Well, there we go, that's one side done. I have chewed slightly into the other side, the second side, with the bottom of the end mill, and I knew that was going to happen. But that's one side done. I've just taken a sort of 50 micron tooth out climb pass back up there to hopefully improve the surface finish. So we'll tidy that up, flip the block round and start doing the other side the same. So there we go guys, that's got that bit done, I think. So we'll get that out of the vise now, deburred, and then we'll go and trial fit it on the slideway and just see how that fits. Right, well we've deburred that now, so that's all tidied up burr wise, so we're just going to try and trial fit that now and see how it fits. It's pretty good. Yeah, pleased with that. It's not perfect. There's a tiny bit of movement in there, but that's pretty good for what it is for a carriage stop. I'm quite pleased with that. So the next job now is I've got to tram the head of the mill back in, and then we're going to drill the fixing holes through this block. This is going to be made in 3 pieces now, so to attach the second piece, which goes basically down here on the front of the slideway, and then also the big hole in the middle that will be the clamp bolt effectively, that will go right the way through to the underside. Okay guys, we've got the head squared back up and trammed back in, and to do that obviously I've had to take the vise off, clean all of the bed down, got the head trammed in, and I've got over the full width of the table, if you like, in a circle, I've got about 1.5 thou is as good as I can get it over that distance, which is reasonable for a hobby mill. Right guys, that's got that piece finished off. So I've just dropped some cap heads in there just to see what that looks like, and that looks fine. So that's for that piece, that's complete now. Other than I might do a bit more chamfering work on the top edge just before we finish it off, but certainly for now that's good enough. So we're going to move on to the next piece, which is the piece that is going to bolt to this with these two M6 cap heads, and that's going to sit down the front of the front of the bedway, if you like. And I've looked at some steel. It's an industrial T-nut, and I've chopped the sort of end pieces off that have got the threaded holes in, so we'll make it out of that. So we'll set that up in a moment in the vise, and we'll start machining that down to make the piece the right size to fit on. Hello guys, welcome back to John's workshop, and in this video and maybe the one after it, we'll see how we go. I'm going to be making a carriage slop. Bell end. Oh man, get a grip. Well, hello guys. For f***'s sake, man. Come on. Oh. Come on, get a grip of yourself. Hello guys, welcome back to John's workshop, and in this video and maybe the one that follows on from it, we're going to be making